Have you ever wondered what happens when you mix things together? Today, we're going to explore how matter behaves when we combine different materials and how scientists classify and describe these mixtures using physical properties. Matter is all around us, and one of the coolest things about it is that we can mix different kinds of matter together to form mixtures. Some mixtures are easy to separate, while others seem to blend so well that it's hard to tell the difference between the materials. By the end of this, you'll know how to investigate and compare mixtures, including solutions that involve liquids and solids. When we talk about mixtures, we mean a combination of two or more substances. Think of mixing a bowl of fruit salad. Each fruit keeps its own shape, and you can easily pick out each piece. This is called a physical change because even though you've combined them, the fruits stay the same. You can classify this type of mixture as a heterogeneous mixture because you can see the different parts that make it up. Now let's compare that to a solution. A solution is a special kind of mixture where one substance dissolves in another, forming a combination that looks the same throughout. One great example is when you stir sugar into a glass of water. The sugar dissolves into the water and seems to disappear, but does the sugar actually disappear? No, it's still there, but it has broken down into such tiny particles that you can't see it. This type of mixture is called a homogeneous mixture because it looks the same all the way through. Solutions are fascinating because they involve solutes and solvents. The solute is the substance that gets dissolved, like the sugar, and the solvent is the substance that does the dissolving, like the water. In our sugar water example, the sugar is the solute, and the water is the solvent. Solutions are important in science because they help us understand how substances interact at the smallest levels. When scientists create solutions, they often study how much solute can dissolve in a solvent before the solution becomes saturated, meaning no more solute can dissolve. Not all mixtures are solutions though. Some mixtures involve liquids and solids that don't dissolve. For example, if you mix sand and water, the sand won't dissolve, and you'll see the sand sitting at the bottom of the glass. This is a mixture, but not a solution. In this case, the sand and water can be separated easily by letting the sand settle or by using a filter. This is another type of heterogeneous mixture where the parts are still separate and identifiable. Mixtures can also involve liquids mixing with other liquids. Imagine mixing oil and water. Even after shaking the container, the oil and water will separate into layers because they don't mix well. Oil is less dense than water, so it floats on top. This is an example of how understanding the physical properties of matter, like density, helps us investigate and compare mixtures. Density is a key property when studying mixtures, as it determines whether substances will float or sink when mixed together. To investigate mixtures, we use observable properties to classify them. These properties include things like whether the substances are solid, liquid, or gas, how they behave when mixed, and whether one substance dissolves in another. By examining these properties, we can figure out what kind of mixture we're dealing with and how to separate it if needed. Scientists use these investigations to develop solutions for real-world problems like cleaning up oil spills or creating medicines. In summary, mixtures can be classified into different types depending on how the substances combine. Some mixtures, like fruit salad, are easy to separate, while others, like solutions of sugar and water, require a closer look. By investigating the physical properties of the substances involved, like density, solubility, and state of matter, we can learn more about how materials interact and how to use these interactions in the world around us. Whether it's separating sand from water or dissolving sugar in tea, understanding mixtures is an important part of understanding the science of matter.